All right, so we're moving on to number 13 here. Okay, we're going to add, this is now add, rational expressions that do not have the same denominator. So the first thing we need to think about is, just like with any fractions, we cannot add these until we give them a common denominator. So the common denominator for 3, 6x, and 2x has to have all the factors of these in them. So since 6 has the factors of 2 and 3, we have to make sure we have a 2 and a 3 in the common denominator, and we have to have the x in the common denominator. And that's going to give us a common denominator of 6x. So all of these denominators are going to be 6x. Now, whenever you change a denominator, you have to also change the numerator. So you look from the old denominator to the new denominator, and what do you have to multiply 3 by to get 6x? Well, 3 times 2x makes 6x, so the numerator also needs to be multiplied times 2x. 2x times 1 is 2x, so this numerator is 2x. This denominator did not change, so the numerator does not need to be changed. To go from 2x to 6x, and it looks like I wrote this wrong here, so we're just going to possibly erase. Nope. All right, we're just going to make this into 6x like it should be. To go from 2x to 6x, you have to multiply times 3. So we will multiply this numerator times 3, and 3 times 3 is 9. So there's our new fractions. Now to add them, we remember that when you add fractions, all the denominators are going to stay the same. So this denominator here will be the same as these, which is 6x. And then we just add across the top. So 2x plus 5 plus 9, well, 5 and 9 are like terms. So those will get added together. So we'll end up with 2x plus 5 plus 9 is 14. Now, it looks like we have a GCF here. So we're going to factor out the GCF here on the top. There's a GCF of 2. So when we factor it out, we have x plus 7. The denominator can also be factored. Even though it's a monomial, it can be factored a little bit. So we're going to factor that 6x into 2 times 3 times x. And the whole reason for doing that is so that we can cancel these 2's here. So what we have left is x plus 7 over 3x. And please remember that you cannot cancel these x's because this one is a term. It's part of this binomial. Although this one's a factor, but this one's not, so they won't cancel. All right, number 14 is another addition. However, this time the denominators are already the same, so we don't have to worry about changing the denominators. So x minus 2 plus x minus 2 minus x minus 2. We've got x squared plus x minus 6. So to add slash subtract these, the denominator is going to be the same. The numerator, we're going to add these terms, x squared plus x minus 6, and none of them are like terms. So they're not going to add together. X squared plus x minus 6. Now, this numerator, x squared plus x minus 6, can factor a little bit more. It's a standard trinomial. So we're going to factor that. And if you don't remember the factoring, you need to go back and review the video for factoring. So this turns into x plus 3, x minus 2. And in the denominator, we still have x minus 2, which is a binomial. And now we can cancel. these x minus 2's. So our final answer is x plus 3. All right, number 15 is a subtract. The rules for subtract are the same as the rules for add. You have to have the same denominator. So looking at these denominators, I can see this is a factor of 2, so definitely we're going to have a 2 somewhere in our common denominator, but this is a binomial that has a GCF. So when we factor out the GCF of 2, we get x minus 2. And you can see then that we need to have a factor of 2, and we need to have the x minus 2. So our common denominator is going to be 2 times x minus 2. Now, to go from this to the old denominator to the new denominator, you look to see what's different. And what's different is it's times the x minus 2. So that's what needs to get multiplied in the numerator. Well, of course, 1 times x minus 2 is x minus 2. This denominator is not changed. This is just the factored form of the same denominator. So the numerator doesn't need to change either. So the denominator here will be 2 times x minus 2. The numerator is going to be x minus 2 minus x. And then when I combine like terms, I'm going to see that this x and this x will cancel each other because this is a positive 1x, this is a negative 1x. And then if you also look at this negative 2 can cancel with this positive 2, but they're opposites. So you're left with a negative 1 in the numerator. So this is negative 1 over x minus 2. All right, moving on to number 16. More subtract here. We've got this trinomial and a binomial here. Well, we can't tell what the common denominator will be until we factor. So let's factor those denominators. X squared minus x minus 6 factors to be x minus 3, x plus 2. X squared minus 4 is the difference of squares. So it factors to be x plus 2, x minus 2. So our common denominator has to have an x minus 3 and an x plus 2. Over here, we've got the x plus 2 covered if we add that one in, so we'll have to add an x minus 2. So our common denominator will be x minus 3, x plus 2, x minus 2. We'll use that for both of these fractions. Now looking from this old denominator to the new denominator, what's added is the x minus 2. So that's what the numerator needs to be multiplied by, x minus 2. And I'm going to distribute this to bring it down here, so that would give us x squared minus 2x. Looking from this old denominator to this new one, what's different is the x minus 3. So this needs to be multiplied times x minus 3. And again, distribute the 2, gives you 2x minus 6 in the numerator. Now we're ready to add these. The denominator is going to be x minus 3, x plus 2, x minus 2. And across the numerator, we have x squared minus 2x. This negative right here needs to get distributed to both of these terms when we bring them over to here. So we have x squared minus 2x. Then we're going to have a minus 2x and a plus 6. Now we need to combine these like terms here. See if this will factor and reduce. So when we combine these like terms, we have x squared minus 4x plus 6 over x minus 3, x plus 2, x minus 2. Now it turns out here, this trinomial looks like it should factor, but there are no factors of 6 that add to make 4. There are factors of 6 that add to make 5. There are factors of 6 that add to make 7, but there aren't any factors of 6 that add to make 4, so it's not going to factor and reduce any more than that. So that's number 16. Number 17 is simplify a complex fraction. So to simplify a complex fraction, we start by looking at the denominators and choosing the least common multiple of the denominators. Now there are no denominators up here because this is a whole number, it's not over anything. So these two denominators are the ones we need to look at. The least common multiple of x and x squared is x squared, so we multiply the entire numerator times x squared and the entire denominator times x squared, and it might be beneficial in the denominator to put this over 1 so that when you multiply your fractions you can see the numerator and the denominators. Alright, so in the numerator this just gets distributed. So it becomes x cubed plus 3x squared. In the denominator, I'm going to write it down here so that you can see what happens. This is top times top, bottom times bottom to give us new fractions here. So this is going to be x squared over x plus, do this one, x squared over x squared. And then we reduce these fractions. Since this is really x times x, one of these x reduces. So we have x. And then, of course, x squared over x squared, both reduce, but it doesn't leave 0, it leaves us with a 1. So this is what we end up with here, x cubed plus 3x squared over x plus 1. Number 18 is the same type of question. We're going to simplify it by first looking at the denominators. We have an x squared, another x squared, and an x, and multiplying the numerator and the denominator by the least common multiple, which again would be x squared. But again, it might be beneficial to put it over 1 because of the fraction multiplication. So when we do this, it's just x squared times 1, and that just makes x squared. Then when we do this, it's times the top and times the bottom. So it's going to be 16x squared over x squared. And of course that will reduce. So we're just going to go over here just a little bit. The first term is still x squared. The second term, the x squareds reduce. So we have minus 16. Oh, that's interesting. All right, now to do this denominator, we'll end up with x squared over x plus 4x squared over x squared. And reducing here, we end up with x plus 4. Now, if you recognize this right here, this is the difference of squares. So we know this will factor to be x plus 4, x minus 4, and the denominator is x plus 4. So we've got some canceling going on here with the x plus 4s. And our final answer is x minus 4. And that's it for this page.